Hello everyone. Today we will discuss an interesting topic, that is application of derivative. I am Dr. Bharat Keshari Swain, lecturer in mathematics, Agarpada Degree College. I welcome everyone to this class, and by the end of the class we will be able to know about the application of derivative, that is how the derivative is applied to the real life problem, and how to find the maxima and minima of a function, and some real life problems. We will be able to know how to solve the problems using the derivatives. So let's start. So first, what is a derivative? Already we have discussed in the previous classes of the derivative that the derivative f dash x measures the instantaneous rate of change of r f at x. So f dash means what? This is the past derivative, that is derivative with respect to x. We know that this is the derivative of x, df by dx, is not it? And this is defined by limit h tends to 0, f of x plus h minus f of x divided by h. This is the definition of a limit. Already we have discussed in the first class of the derivative, and it is denoted by dy by dx, and or f dash, that means past derivative, or capital D of f. Is not it? These are the notations of the derivative. Now come to next page. Next is rate of change and velocity. Now, if the position is given by s of t, that means s is for displacement, and this is a function of t. And if velocity is defined, already we have all of you know about the velocity, that is rate of change of displacement, and this is nothing but ds by if I write v of t, v of t will be ds by dt, isn't it? ds by dt, and this is denoted by s dash, and since it is a function of t, so s dash of t. Similarly, acceleration f dash t, that means this is the rate of change of velocity, and this is a of t, that means acceleration, and this is a vector also, we can denote it like this, and this is your d by dt of v. This is the rate of change of velocity, and since velocity is s dash, so we can write this as d by dt of ds by dt. Okay, d by dt of ds by dt, and this will be a of t will be s double dash t, because this is the double derivative, second derivative, d by dt, again d by dt, again d by dt of s, so that's why it will be d square by dt square of s of t. So therefore it is s double dash t. Okay, so s double dash means what? This s double dash means double derivative of s with respect to t. So for example, suppose s of t is given by 5t cube minus 2t square plus 3. Then what will be v of t? What will be v of t? We know that v of t is what? ds by dt. ds by dt. And so we have to differentiate only with respect to time. That means d by dt of 5t cube 2t square plus 3. So dy by dt of 5t cube, 5t cube means this is the derivative of t cube is 3t square. So 5 into 3t square means 15t square. Then minus 2 into derivative of t square. Derivative of t square means this is a 2t. So 2 into 2t means 4t. So 15t square minus 4t, and derivative of 3 is, we know that this is derivative of constant is 0. So derivative of 3 is 0. So b of t equal to 15t square minus 4t. Okay, this is your velocity. Similarly, we can find the acceleration also. Acceleration will be again derivative of v of t. This is your a of t means dy dt of v of t, and just we have to differentiate this velocity with respect to time again. And what will be this? 15t square means derivative of t square will be 2t. So 15t square means 30, that means 30t square. Isn't it? Again I will write here again the derivative of, that means a of t. Okay, a of t will be dy dt of v of t, and that is equal to dy dt of 15t square minus 4t, and therefore that is equal to 30t minus 4. Okay, because t square is derivative of t square is 2t, so 15 into 2t equal to 30 into t, then derivative of 4t is 4. So result is 30t minus 4. So this is how we can find the velocity and acceleration if your displacement, your s of t is given using the derivative, because we know that velocity is rate of change of displacement and acceleration is rate of change of velocity. Okay, now come to next page. Okay, this is a problem, how we can find the rate of change of area of a square if uh, the side of square is increasing. Okay, see the statement of the problem. What is the statement of the problem? At a certain instant, your the side of a square is increasing at dx by dt equal to, so dx by dt means rate of change of x. If x is the side, if x is your side, then rate of change of side of a square is increasing means what? It is changed with respect to a time. So it is denoted by dx by dt. So side of a square is increasing at 0.3 centimeter per second. 0.3 centimeter per second. So we can denote it as dx by dt equal to 0.3 centimeter per second. And at the same time, the area of the square is increasing. The area of the square is increasing, and this is area, so it is increasing also, so it is changing, so we can denote it as dA by dt. That means the area is increasing with respect to time. Area is changing with respect to time. So that is given as 30 centimeter square per second. So what is your question? Question is find the length of the side of the square. Find the length of the side of the square at that instant. So we have to find the length of the side. This is the statement of the problem. This is the problem. Okay, so suppose we come to the next page. This is the solution. Okay, this is the solution. See here, let the side of the length, let the side length, that means length of the side is x centimeter. So what will be the area? Area of square means we know that side into side, this is your x square. So if x is the side, then the area is x square. So if you differentiate with respect to time, this is your dA by dt in the left hand side, then the right hand side will be dy dt of x square, dy dt of x square. So directly we cannot find the differentiation of x square with respect to time, so you have to use chain rule. That means we can take it as dy dx of x square, then again dx by dt. This is the chain rule we have already discussed. So therefore dy dx of x square, means 2x, and dx by dt, so dA by dt is equal to 2x into dx by dt. Now substitute the known values, that is dA by dt in the previous page, dA by dt, because rate of change of area, it is given as 30. This is a 30 centimeter square per second, and dx by dt also given in the question, that is 0.3 meter per second. And therefore if we solve for x, it will be 30 divided by 2 into 0.3, that is 0.6. So 30 divided by 0.6, so therefore it will be 50 centimeter. 0.6 means you can write it as 6 by 10, so it will be multiplied with the numerator, so it will be 50. So 30 by 0.6 is equal to 50 centimeters. So the side of the square at that instant is 50 centimeter. Clear, everyone? Okay. Next, come to the slide where we will discuss another example, another question, that is find the rate at which the volume of a spherical balloon also. Find at the rate, this is your question. Find the rate at which the volume of the spherical balloon is increasing when its radius is 2 meters. So the spherical balloon, the radius of the spherical balloon is given, it is 2 meters. And again, what is given? The radius is increasing at the rate of 0.3 meter per minute. Okay, so the radius is increasing, so rate of change of radius, so we can, with respect to time, so also it can be denoted as dr by dt, because it is changing. This is the rate of change of radius with respect to time, so therefore it is the derivative of r with respect to time. So rate of change means is the derivative. Okay, so rate of change of r with respect to time. So dr by dt is 0.3 meter per minute. So it is given, and the radius is given as 2 meter. And what is to find? To find the rate at which the volume is increasing. The volume of what? The volume of spherical balloon. So we have to find the volume of the spherical balloon and then find out the rate at which it will be increasing. So come to the next slide for the solution. This is the solution. What is given? R equal to 2 meter. Already we have read in the previous page that r equal to 2 meter radius. Then rate of change of radius is given, that is 0.3 meter per minute. And so if r equal to radius, that is your r equal to 2 meter, then what will be the volume? So volume of the sphere, we know that the formula is what? 4 by 3 pi r cube. 4 by 3 pi r cube. So if it is 4 by 3 pi r cube, and we have to find the rate of change of volume, so rate of change of volume means dv by dt, because rate of change means derivative. Rate of change means derivative of the velocity with respect to time. Sorry, rate of change of volume with respect to time. So dv by dt is equal to, so just differentiate it. In the left hand side is dv by dt. So the right hand side it will be 4 by 3 is constant, pi is constant. So only we have to differentiate r cube, d by dt of r cube. So we see here, this is r cube, this is with respect to time t. So directly you cannot find the derivative, so we have to use the chain rule. So using chain rule, it will be what? D by dr of r cube into dr by dt. So d by dr of r cube means 3r square, is not it? 3r square into dr by dt. And in the previous, it was 4 by 3 into 5. So 4 by 3 into 5, 4 by, okay, see here. So it is your 4 by, okay, see here, it is 4 by 3 into 3r square into dr by dt, is not it? So 3 cancel, so 4r square, sorry, 5 is also there, is not it? So 3 cancel, so 4 pi r square into dr by dt. So dv by dt is given by as 4 pi r square into dr by dt. Now dr by dt is given, r is given. Okay, just put the values of r and dr by dt. So r is 2 meter and dr by dt is 0.3 meter per minute. So if you put all these values, we will get, okay, so here check, dv by dt equal to 4 pi r square, that means 2 square into 0.3. Just solve for dv by dt and it will be 4.85. Okay, you can see 4 pi, is not it? 4 pi into 4 into 0.3 means 3 by 10. Just solve for this. So 2 into, okay, if you solve this, 4 into 4, 16 into 3. 4 into 4 into 16, that means 16 into 3 in 48. So 48 by 10 means 4.8. So 4.8 into 4.8 into 5 meter cube per minute. Okay, so the volume of the spherical balloon is increasing at the rate 4.85 meter cube per minute. So this is how we can find the rate of change of volume, rate of change of square. Okay, if the sides is given, if the radius is also given, we can find the rate of change of volume of a spherical balloon. And in this case, it is increasing, so it is written as dv by dt, and that is found as 4.85 meter cube per minute. Now come to another concept, that is tangent and normal to the plane curves. So using the derivative, how to find the tangent and normal to the plane curve. So the tangent line here, see the tangent line. What is the tangent line? The tangent to a curve at a point is the straight line that just touches the curve at that point. It is also defined in the school level also. The tangent means what? It is the line, it is the straight line that touches the curve at that point. So this is the tangent to a curve at a point. So it has the same slope as the curve at that point. If the curve is y equal to phi of f of x, then the slope of the tangent is given by dy by dx. If y is the curve, then the slope of the tangent is given by dy by dx. So just remember this. What is dy by dx represents? It represents what? Slope of a curve, and curve is what? Y. If y is the curve, then dy by dx is the slope of the tangent. Okay. Now, what is the normal line? The normal line is the line perpendicular to the tangent at that point of the contact, and it intersects the curve at same point. Okay, so see here, if I draw a curve like this, see, if I draw a curve like this, and this is the point where I can find this is the tangent. If this is the point, this is the tangent, and if I draw a perpendicular line, at that point, then this is the normal line. This is the normal line, and this is the tangent line. Okay, and So only we have to remember what? If y is the curve, if y is the curve, if y is the curve, then dy by dx is the tangent of the, sorry, dy by dx represents the slope of the tangent. So another thing we can see here, if slope of the tangent is given by dy by dx, so at a point means at x equal to a, then what will be the slope? Now if you can see here, if the slope of the tangent is dy by dx, if slope of the tangent is dy by dx, then the slope of the normal will be what? Because the tangent and normal, they are perpendicular to each other. So therefore we know that slope of two lines, if they are perpendicular each other, then if slope of one is m1 and slope of another is m2, slope of other is m2, then m1 into m2 will be equal to -1, because product of two slopes is equal to -1 if they are the slope of the perpendicular lines. So therefore if dy by dx is slope of the tangent, then slope of normal will be what? And it is m, so it is -1 by m, is not it? So that means if m is the slope of the tangent, then -1 by m is the slope of the normal, because product of two slopes will be -1. If they are perpendicular to each other, product of two slopes is -1. So if slope of the tangent is known, then slope of the normal is known, we can find the equation of the tangent line, also equation of normal line. So what are the equations? We know that if one point is given and the slope is given, one point formula, we know that y minus y1. What is the equation? Y minus y1 is equal to m into x minus x1. m into x minus x1. And what is x1 y1? What is x1 y1? These are the this is the point. This is the point where the line is the slope is, means your tangent is drawn. This is the point, and this is the point through which the line is passing. And what is m? M is the slope of the tangent. So therefore the slope of the tangent line. Therefore, the equation of the tangent will be y minus f of a, and what f of a equal to m into x minus a, equal to m into x minus a, because the point is what? Here point is, if this is the line, and if the curve, okay, I will draw again for you. I will draw again here, because if this is your curve, and this is a point like this is a tangent line, and what is the point here? If it is a, and this point is f of a, this point is f of a, so the point is what? The point is a f of a, point is a f of a. So x coordinate is a, y coordinate is f of a. So your equation will be y minus y1. Y1 means f of a is equal to m into x minus x coordinate. X coordinate means a. Okay, so this is the equation of tangent. This is the equation of tangent. And similarly, we can find the equation of normal like this: y minus f of a, y minus f of a, and the slope into x minus a. And what is the slope here? Because slope of the tangent is m, then the slope of normal will be -1 by m. So slope into x minus a. So this is the normal line equation. So using this equation, we can find the equation of tangent, equation of normal. Okay, so see here some examples. Find the equation of tangent and normal to the curve y equal to x square plus 3x plus 1. Y equal to x square plus 3x plus 1. So at, what is the point? At y is equal to 1. So compute y at x equal to 1, because we have to find the point. We have to find the point. So if x equal to 1, what will be y? Y will be 1 square. Just put the value of x here. So 1 square, 3 into 1 plus 1, so value is 5. So the point is 1, 5. So point is 1, 5, where we can find the equation of tangent and normal. So now find the slope. So if y is given as x square plus 3x plus 1, so the slope of the tangent, we know that slope of tangent is dy by dx. If y is x square plus 3x plus 1, then slope of the tangent will be dy by dx. So just differentiate this with respect to x. So if you differentiate this, the derivative of x square will be 2x and derivative of 3x is 3. So 2x plus 3. So the slope of the tangent will be 2x plus 3, and at the point 1, 5, just put the value of x here. X is 1. So therefore the point 1, 5, at the point 1, 5, the slope will be what? 2 into 1 plus 3, that is equal to 5. So this is the slope of the tangent at the given point. And so we have to find the tangent equation. So tangent equation means what? Y minus y1. So what is the point? 1 and 5. So y coordinate is 5. So y minus y coordinate is equal to the slope. Slope means 5. Slope into x minus x coordinate. X coordinate is point is what? 1 and 5. Point is 1, 5. So y minus 5 equal to 5 into x minus x coordinate. X coordinate means 1. So y minus 5 equal to 5 into x minus 1. Similarly, we can find the normal equation. What is the normal? Y minus 5 only. The slope will be changed. So if 5 is the slope of the tangent, the slope of normal will be minus 1 by 5. Is not it? If 5 is the slope of the tangent, then the slope of the normal will be minus 1 by 5, because the slope of normal into slope of tangent is minus 1. Is not it? Because they are perpendicular to each other. Therefore, if 5 is the slope of the tangent, then slope of the normal will be minus 1 by 5. So just put the value of slope of the normal and into x minus 1, because point is 1, 5. So equation of normal is y minus 5 equal to minus 1 by 5 into x minus 1. Right. Now come to another slide. This is increasing and decreasing function. Increasing and decreasing function. So how it is defined? A function f is said to be increasing on an interval I if x1 less than x2 in I, then fx1 less than equal to fx2. If x1 less than equal to x2, then fx1 less than equal to fx2. So this is the definition of increasing function. And if x1 less than x2 implies fx1 less than fx2, this was less than equal to, so it is only increasing. If fx1 less than fx2 only, not equal to is there, equal to is not there, so fx1 less than fx2, so this is strictly increasing. F is strictly increasing on I. Okay, so how it is how it can be defined in the graph? So if x1 less than equal to f2, so suppose it is x1, this is x2, this is x1, this is x2, suppose 1 and 2. So if this is x1 and x2, and here is the graph, here is the graph. So you can check here, this is your fx1, this is your fx2. If x1 is less than x2, means x2 is greater, then fx2 is also greater. If x1 is less, then fx1 is also less. So this is an increasing function. This graph is a graph of an increasing function, because it is increasing as the value of x is increasing. As the value of x increases, because this is your x, this is your fx. So as x increases, fx also increases. Okay, so this is how we can define the increasing function. And decreasing function is just opposite to it. Decreasing function is just opposite to it, like this. If it is x1 and x2, then the graph will be like this. x1, x2, x1, x2, fx1, this is your fx1, this is your fx2. So fx2 is less than fx1. Okay, so this will be decreasing function. This is your increasing function. Is not it? So this is the definitions of increasing function and decreasing function. If equal to is there, it is only increasing. If not equal to there, so this is your strictly increasing. Similarly, for decreasing function, if x1 less than x2, if x1 greater than equal to fx2, this is your decreasing. And if x1 less than x2 implies fx1 greater than fx2 only, not equal to, then it is then f is strictly decreasing on I. Now, next definition is what? A function is called monotonic if it is either increasing or decreasing. If it is either increasing or decreasing, then we can say a function is monotonic. So monotonic means it may be increasing or decreasing function. Now come to the another definition. A function f is said to be increasing at a point C. At a point C, if there is an open interval I containing C such that for every x belongs to I, x less than C, fx less than f of C, and x less than greater than C, then fx greater than f of C. Okay, so f is said to be increasing at point C if there is an open interval I containing C such that for every x belongs to I, x less than C implies fx less than f of c, and x greater than c, that implies fx greater than f of c. So for every x belongs to I. Similarly for decreasing, this is the same definition, but it is c containing c. So c is a point. At a point we have to define. In the previous slide it is generally defined, but here for a particular point c. Similarly for decreasing at a point c, then if x less than c, fx greater than equal to greater than f of c. If x greater than c, that implies fx less than f of c. Okay, so these are the definition of increasing function and decreasing function. So we have observed that if a function is increasing or decreasing on an interval I, then it is increasing or decreasing at each point of I. So at each point of I, if a function is increasing on an interval I, then it is also increasing at each point of I. In the interval, there are so many points. There are infinitely many points. So if it is increasing on an interval I, that means what? It is increasing at each point of I. At each point of I. Okay, next come to the next slide. So this is the derivative test for increasing and decreasing at a point. So to check the function is increasing or decreasing at a point, then we can use the derivative test. So what is the theorem which show the test? That means this is also also called first derivative test, because only we use the first derivative for this test. This is also called what? First derivative test. This is also called first derivative test. So what is the test? It is given by a theorem. Let f be a function defined on an open interval containing point C. Then if f dash c greater than 0, then f is increasing at c. If f dash c less than 0, then f is decreasing at c. So just remember these 2 points. If f dash c greater than 0, then f is increasing at c. If f dash c less than 0, then f is decreasing at c. Okay, so see here one example to test whether the function fx, test whether the function fx equal to x cube minus 27x plus 6 is increasing or decreasing. So solution. So we know that f dash, so we have to find first derivative f dash x. So just find the derivative of first your f of x. So derivative of f of x is 3x square minus 27. And if you factorize this, it will be just take 3 common and 3 into x square minus 9, and we know that x square minus 9 is x plus 3 into sorry 3 into x plus 3 into x minus 3. So this is your f dash x. And if I take f dash x greater than 0, because for increasing we know that f dash x greater than 0. So if f dash x greater than 0, that implies what? X plus 3, just take this value. So x plus 3 into x minus 3 greater than 0. Okay. So if x plus 3 into x minus 3 greater than 0, then this happens when x plus 3 and x minus 3 have the same sign, because it is greater than 0 means it is must positive. Okay, it must be positive. So when the product of two factor is positive, it may be both positive or both negative, because product of two positive number is positive and product of two negative number is also positive. So therefore x plus 3 and x minus 3 have same sign. So if they have same sign, suppose it is positive, then x plus 3, then x plus 3 greater than 0. So x plus 3 is greater than 0 means x and x minus 3 also greater than 0. So x minus 3 greater than 0 means x greater than 3. X greater than 3 we found x greater than 3. Okay. Now if we take x, if we take x less than and both factors as negative, so if x plus 3, if x plus 3 less than 0, then x is less than minus 3. Okay, so therefore x is less than minus 3 or x is greater than 3. So hence this is what? This is your mod x, because x less than minus 3 and or x greater than 3. So if therefore it is mod x greater than 3. Okay, so minus the per mod x greater than 3, then f is increasing. And if x similarly we can find for decreasing, we will take this factor less than 0. For the decreasing function we can take what? X plus 3 into x minus 3 less than 0. One is positive, another is negative, because this is the product of two factor and it is less than 0. That means one is positive, another will be negative. So therefore for mod x less than 3, f dash x less than 0, so f is decreasing. So what we got? What we got? F is increasing when mod x greater than 3 and f is decreasing when mod x less than 3. Okay, so f is decreasing for the interval minus 3 to plus 3. Okay, so this is the interval. This is your minus 3 to plus 3. This is 0. So from minus 3 to plus 3, it is decreasing. This is your decreasing, and greater than 3 and less than minus 3. So greater than 3 or less than minus 3, it will be, because what we found, this is minus 3 to, this is minus 3 to plus 3. Okay, and this is 0. So here in this interval minus 3 to plus 3, it is decreasing, and greater than 3 and less than minus 3, it is increasing, and it is also increasing, and in this interval it is decreasing. Okay, so this is how we can find the interval where the function is increasing or decreasing using this first derivative test. Okay, so we will meet in the next class for the next concept of this application of derivative maxima and minima, and we will complete this application of derivative in another class. Okay, so up to now what we learned that what we learned that first is how we can find the rate of change of a square if a side is given, then rate of change of a volume of a sphere if its radius is given, and if displacement is given, how to find velocity and acceleration. Then another thing is increasing function and decreasing function, the definition of increasing function and decreasing function, and using the fast derivative test. That means your if f dash greater than 0, function is increasing, and f dash c less than 0, then function is decreasing at that point. Okay, so in the next class we will discuss further uh, topics of this application of derivative maxima and minima, then again first derivative test, then second derivative test to find this maxima and minima. Okay, and the related problems we will discuss in the next class. Thank you. Okay, so stay with me, and we will be able to solve all these problems of application of derivatives. Okay, thank you for this patience. We will meet the next class. Thank you.